Hey everyone, this is the video for lesson 9.8. It's on cubic functions. This is the last section of chapter 9. And that last section, 9.7, was our last section of quadratics, like parabolas. Now we're going into cubic functions. So, a little bit different. A lot of the same steps though. Alright, so to find the area of a square, you use the expression x squared, right? Imagine a square, close your eyes. And the two sides are x and x because it's a square, they're all the same. So the area is length times width, x times x is x squared. To find the volume of a cube, you would use the expression x cubed, or x to the third. A cube, all the sides are the same, so length times width times height for the volume. And if they're all x, x times x times x is x cubed, or x to the third. If you wanted to find the side length of a cube when you know the volume, you take what's called the cubed root. So it's like the square root with a little 3 in there. To do this in your calculator, you type math, so that's over on the left column, math, and then 4. So you do like math 4, 64, enter, and they'll give you 4, because the cube root of 64 is 4. That means 4 times 4 times 4 is 64. That's what the cube root means. It just finds the number that would multiply itself 3 times to get to the number you want. Alright, so this right here is a cubic function. Notice how it would be a parabola if we just continued up here, but instead it reflected down. So we're in the negatives and then we're in the positives. So again, it looks like a snake. That's usually what I call it. It should go through the origin and it should go from the negatives to the positives. If it didn't, then there was some type of transformation, like a translation, a reflection, a stretch, or a shrink. Like all the rules are the same. Alright, so write an equation for each of these graphs. They're just transformations of that parent function. So the parent function on the last slide, that's just y equals x cubed. And the same rules apply. So we got the minuses and the pluses, the thing outside. I'm going to let you know that neither of these have a stretch factor, and I'll show you in the next couple of slides what you do when there is a stretch factor. So this first one, the only thing that happened was instead of going through the origin, it goes through -1, so it went down 1. You could also write this as y plus 1 equals x cubed, if you're still into that, but this is what you would do in a calculator. This one, instead of going through the origin, it went over 2, up 1. So to the right 2, which is -2, and then up 1. Again, you could put this plus 1 over here to be -1 if you want. Doesn't matter. Alright, so I have this graph now. So this is a cubic function. It looks nothing like the cubic function you've seen in the last couple of slides. It's more snaky, I think. It's got more twists. It's crossing the x-axis at multiple points. You wouldn't even be able to tell where the center is. You know how like the center usually goes to the origin? Like we have no clue where that is now. So now we have to do a whole new method. So first you decide what are the roots of the function. So remember the roots are where you cross the x-axis. So that would be -3, -2, and +2. Now you write the equation in factored form. So remember that's like x minus r1, x minus r2. In this case there's 3 of them, so you'd also have an x minus r3. And then I say leave a space for the stretch shrink factor. So y equals a, that's my space for the stretch shrink factor. The -3 root becomes x plus 3, remember it flips. The -2 root is x plus 2, +2 is x minus 2. Now you have to solve for the stretch shrink factor by plugging in the given point. The book should always give you a point that they want you to plug in. If they don't, you just find a pretty point on the graph, so like where it crosses like an exact like corner. Like so if it went through, like this one's pretty good too, right here, because it goes through an intersection. Okay. So now you take the point 0, 6. So over here you should say that 0 is x and 6 is y. We know that. We know a coordinate point is x comma y. So now for the y, we plug in the 6. For the x's, we plug in 0. All of the x's get a 0. Then you simplify. We know that 0 plus 3 is 3, 0 plus 2 is 2, 0 minus 2 is negative 2. Then on the right side, you multiply these numbers. 3 times 2 times negative 2 is negative 12. And then you divide both sides to get a by itself. 6 divided by negative 12 is negative a half. Therefore, our shrink factor, is a half, and it also was reflected. This will find the reflections also. So you rewrite, meaning you take this, but instead of a, you put the stretch factor in. So y equals negative a half, x plus 3, x plus 2, x minus 2 is the equation in factored form of this graph. All right, look at this one. Notice how we only have 2 roots this time, even though it's a cubic function. A cubic function means you should have 3 roots. We only got 2. Let's see why. The graph contains a double root at x equals 1. See how this bounces off. Like every other root we've seen so far, it goes straight through. So like this one went straight through. This has a double, so you'll see what that means in a second when we write the equation. All right, so we're going to write the equation for the graph. We start the same way, where we write it in factored form and we leave a space for the stretch factor. Okay, so negative 2 is one of our roots, so that's x plus 2. 1 is one of our roots, so that's x minus 1. But that's a double root. Since it bounced off, you have to put a square with that one. That accounts for the 3 roots. We have 1 of these and 2 of these. Therefore, 1 plus 2 is 3 roots. 1 just shows up twice. You plug in the point, so we know x is 2, so we're going to plug that in for our x's. We know y is 4, so we plug that in over there. Then we simplify. 2 plus 2 is 4. 2 minus 1 squared is 1. We multiply 4 and 1 to get 4. We divide. So this one did not have a stretch or shrink factor, did not have a reflection. It's up to you if you put a 1 in for a here or just put nothing there. I usually like to prove to you guys that I know that there's no stretch or shrink, so I put the 1, but always up to you. All right, last one, definitely the harder one. So we want to find the exact x-intercepts. When you see the word exact, you know you're leaving things in square root form when possible. And it's of this equation right here. So this time they're not giving you the factored form. They're not giving you a graph. Your first step is to take this and plug it into your calculator and adjust the window so you can see it cross all 3 times. It should cross 3 times unless there's a double root. These types of problems, you're going to see it cross 3 times. So one root is obvious. It's x equals 2. This one right here. They even have the Spider-Man on it. So 2, 0. So we got one of them. That means we have to find the other 2. The other 2, see how they cross in the middle of 2 x values? That means they're going to be decimals. So you might think, oh, I can just do you can put y2 as 0 and then do the intersect thing, but that's going to give you a bunch of decimals. I want the exact, meaning with square roots. The calculator can't give you that. So now that we know that one of our roots is x equals 2, we need to use a box. Thing is, the box is going to be bigger because we have a cubic function. If you ever have a cubic function, you're going to have a 2 by 3, where a parabola was always 2 by 2. So it changes a little bit. The steps for factoring this are very similar. We know that the first number and the last number can't be affected by any other thing, so you can put those in right away. X cubed and negative 2 go in these 2 spots. And then we also know one of the roots. X equals 2 is one of the roots. That means our factored form is x minus 2 because it flips. So now it's like a puzzle. What can we fill in next based on what we know? If we know this is x cubed and we have an x here, you have to think what times x is x cubed? That would be x squared. But now we have x squared and negative 2, which means we can fill in this box as negative 2x squared. All right, next, we know we need to get up to positive 2x, and we have negative 2x. So what plus negative 2x squared is positive 2x squared? That would be 4x squared. But now we know we have x and 4x squared, so what must have been up here? What times x gives me 4x squared? That would be 4x. Now we can fill in this box because 4x times negative 2 is negative 8. Last thing, we have negative 2 and negative 2, which means this must have been a 1 up here. Therefore, 1 times x is 1x. So we filled it out. We know that we have x minus 2, and then we also have this piece. This piece tells us the other two roots. In order to find what those roots are, we have to use the quadratic formula. So remember, to start the quadratic formula, you find the discriminant, b squared minus 4ac, that's 12. Then you plug it into the quadratic formula. So negative b plus or minus the square root of the discriminant all over 2 times a. In this case, a was 1, so I just write 2. So the 3 roots of the equation are the obvious one, and then these two. There's 2 roots here, one with a plus, one with a minus. Okay, this is the hard problem. The other one's not so bad. All right, here it is. Try to find a good range of problems. I'm pretty sure 13 is a review, which is always fun. 11 will help you with the box thing if you're getting confused on that last problem. There's a problem very similar to number 2 on the quiz. What else? I'm not sure what else. I'll take a look at it in class if you have questions about which ones you should do, but I really do think 2 is good, and then the reviews are always good. Alright, so make sure you take good notes, you mark as done, you take your Google form quiz, and have a good night.